My teacher once made the graph a quadratic function, but I don't get it.
Do you know where to start?
No.
First, you have to determine whether the graph opens up or down. The graph of a quadratic function is called a parabola.
Isn't it an African virus?
No. You are thinking of the Ebola virus. I said parabola. You are not that smart. I think we need to start by graphing a parabola in standard form. When a quadratic function is in standard form, it will be ax squared plus bx plus c. Mr. Hand will demonstrate. Hello, Mr. Hand. Mr. Hand will write our quadratic function in standard form.
How is that supposed to make any sense?
This is a general equation. We'll let Mr. Hand apply it with quadratic function f of x equals 3x squared minus 6x plus 2. The coefficient of x squared, or the number in front of it, is 3. This is a. The coefficient of x is negative 6. This is b. And c is 2. Stop freaking out, Mr. Hand.
Okay. That makes sense. But what does that have to do with the graph of a parabola?
When a is positive, the parabola will open up and look like Mr. Hand's smiling face. When a is negative, the parabola will open down, and it will look like Mr. Hand's frowny brother, Mr. Stinky.
So when there is not a minus sign in front of x squared, it opens up, and when there is a minus sign in front of x squared, it opens down.
You are much smarter than you look. Now that we know how to determine whether the graph of the quadratic opens up or down, we need to find the axis of symmetry.
There in London.
Huh?
The axis of symmetry. That is a band, right?
No. It is a vertical line that passes through the vertex of a parabola. Perhaps Mr. Hand can help. The equation of the axis of symmetry is x equals negative b divided by the quantity 2 times a. Now we substitute negative 6 for b and 3 for a in the equation. Mr. Hand, will you please circle the substituted values? Thank you, Mr. Hand. Next, we will simplify the expression. The negative 6 becomes positive, and 2 times 3 gives us 6 in the denominator. This is of course equal to 1. So the equation of the axis of symmetry is x equals 1. I will use the power of my chest computer to show you the graph. The graph of the axis of symmetry is a vertical line that passes through x equals 1 on the x-axis.
You say that the axis of symmetry passes through the vertex? I get that. But what is a vertex?
Well, the vertex is the minimum or maximum y-value of the graph of the parabola.
I have no idea what that means.
Mr. Hand will show you. For the graph of a parabola that opens up, a is positive. The vertex is the very bottom, or the minimum y-value. I think that Mr. Hand is sleepy. For the graph of a parabola that opens down, a is negative. The vertex is the very top, or the maximum y value.
Okay. So the vertex is kinda like the point on the triangle.
Yes. Now let's get back to the axis of symmetry. Mr. Hand showed us how to calculate it, and I used my computer chess to graph it. We found that it is the line x equals 1. The vertex of the parabola is on this line. Mr. Hand, wake up and show us how to find the vertex of the parabola. Mr. Hand will substitute the value 1 in for x in the equation of the parabola that we are graphing. He likes to use function notation. We use this notation to say that when we use 1 as our input, it outputs a number. Mr. Hand can't talk.
He's a hand.
I will tell you what he is writing. f of 1 equals 3 times 1 squared minus 6 times 1 plus 2. Now, Mr. Hand will simplify because he is my human hand slave. He gets 3 minus 6 plus 2. This simplifies to -1. So when x is 1, y is -1. This can be written as a set of coordinates, or a point on the graph.
So when I substitute a number for x in the equation, what I am really doing is trying to find a point on the graph.
Yes. When you plug 1 in for x in the function, it gives you y equals -1. This is a point on the graph. In this case it is the vertex. Let me add it to my computer chess graph.
That's cool. I am a box. That point should be on the point of the parabola, right?
Exactly. We are almost done. We know that the graph opens up because it is positive. We know the equation of the axis of symmetry and the coordinates of the vertex. Now we need some more points to finish our graph. Mr. Hand, show us how to find more points on the graph. Mr. Hand likes to represent functions as tables too. He's drawing a table and writing the x and y values of the vertex. Now he has chosen to find the y coordinate on the graph when x is 0. He will substitute 0 in for x in the function. Simplify it, Mr. Hand. When Mr. Hand simplifies, he gets that f of 0 equals 2. He will put this value into his table. Mr. Hand, where are you going? Oh, he wants to show us that what he did was find the coordinates of a point on the graph. It is the ordered pair 0, 2.
So when x is 0, f of x is 2.
Yes.
Is that the same as saying that when the x coordinate of the graph is 0, the y coordinate is 2?
Yes. You are getting it, box robot. Now I will plot the points from our table on my robot computer chest. We have already plotted the vertex. This is the point 0, 2. We can find another point by reflecting the point 0, 2 about the line x equals 1. This gives us the point 2, 2.
Where you get the last point from?
The graph of a parabola is symmetric. Any point to the left of the axis of symmetry will be the same distance from the axis of symmetry as the point on the right.
So like if I folded the parabola in half with the axis of symmetry as my folding line, the left side would line up with the right?
Yes, box robot. Let's look at the graph. My robot computer chest will connect the points and finish our graph.
It looks just like I thought it would.
You have come a long way, Box Robot. Say goodbye to Mr. Hand.
Goodbye, Mr. Hand.